In this video, I will demonstrate how to perform the chi-squared goodness of fit test using the list feature of your calculator. In another video, I will show you how to do the same thing using the matrices in your calculator. For now, though, we'll use the goodness of fit test using the list feature. I'm going to be following example 3 from the goodness of fit section of chapter 11, the chi-squared distribution. In example 3, we are to compare a sample of far western United States families with statistics that were gathered from the entire country, apparently, in terms of the number of televisions in these families' households. In order to complete this test, we need to compare the observed frequencies with the expected frequencies. In order to do that, we go into Stat and edit your lists. And I'm going to start by entering the observed frequencies. And these are the frequencies that were observed for the numbers of televisions in the sample of 600. There were 600 total. Next, we enter the expected frequencies. These are the frequencies that are expected if the sample was representative of the population of all United States residents or United States families. These are computed for you in example 3, and if you need help computing these expected frequencies, be sure to watch the PowerPoint presentation on chi-squared, or read your book and you'll find an instruction there. Anyway, these frequencies are given in a table just below the observed frequencies. Next, in order to compute the chi-squared test for goodness of fit, we need to go through some calculations. The first is to compute the difference between these two columns, and then we will square that difference and then divide that difference by the expected frequencies. And you could do this all in one step. I'm going to do it in 3 steps just so that you can see each step individually. So the first step is to find the difference. To do that, go up to list 3 and then select the header for list 3, press enter, and then, press the enter button, and then type list 1 minus list 2. And the calculator will automatically compute the differences. Go over to list 4, and you're going to square each of these differences. So press enter once again, and then press list 3. Whoops. Let me go back here, try again. List 3, and I'm going to square these numbers. You should get the same numbers that I have here. Then we'll go over to list 5, and in list 5 I'll divide each of these numbers by the expected frequencies. The expected frequencies are found in list 2. This is exactly what the book does, only it does it in a table, well, similar to what we're doing here. So list 5 is going to be equal to list 4 divided by list 2. Next, we're going to have to add up the numbers in that column. So to do that, I quit this, quit. Then we go to the list, and then math, and then go down to sum, and we're adding up list 5. So there's the chi-squared value for this problem. Next, we want to compute the p-value for this problem. To do that, you click Second, Distributions, and you'll notice that there is a chi-squared PDF and a chi-squared CDF. We want the CDF. So select chi-squared CDF, and now the syntax is the left bound, the right bound, and then the degrees of freedom. In this case, the left bound, we're interested in everything to the right of this number. The chi-squared distribution is a one-tailed distribution, and it's always the stuff to the right that you're going to use for your p-value. And so this number that we're using here is actually a left bound. So I'm going to insert the answer that I just got, or I could just retype that number. And then as the right bound, I want to go all the way as far as I can to infinity, ideally, but of course the calculator can't do infinity, and so I use the biggest number that the calculator can handle. Whoops, I almost forgot the degrees of freedom. In this case, there were 5 categories. There are 5 minus 1, which is 4 degrees of freedom. That should do it. So you can see that this number is very small. Remember that an e there represents an extreme number. In this case, e to the negative 6 means that this number should be interpreted as 0.2345, 5 zeros, and then the number itself, 577. It's scientific notation for this number. And so in this case, we will reject the null hypothesis and say that there is evidence to suggest that there's that the Western states are not a good representative for the population of the United States in terms of number of televisions per family.